So the original Black-Scholes PDE does not contain the expected return alpha, only the risk-free rate. And it does that in the same way that when we were doing binomial lattice pricing, binomial tree pricing, we could ignore the real return on the stock and assume that the effective return on the stock was the risk-free rate, but we needed to use risk-neutral probabilities P star. We also saw that we could attempt to price that option with the real-world returns of the stock and the real-world probabilities of price movements, but after we made all the adjustments for the unknowns in that process, we came back to the same risk-neutral price that we got originally in our lattice. And this Black-Scholes analysis provides the same conclusion, namely that if you price options assuming risk-free returns and a risk-neutral probability distribution, which comes from the DZ star term, you will in fact get the correct price of the option, and you cannot force that differential equation to reflect alpha, because when you've done that correctly, the alpha terms cancel out. Now remember how in the differential equation we ended up with an E star. Where did the risk-neutral probabilities come from in the process? And you may recall that they came from starting with the stock, obeying a process that involved an alpha, and then we reduced the drift of that process by the risk premium, and in effect stuck a new drift term into the old Ito process that was the old Brownian motion that was in the original process. And then we changed probabilities to get rid of that drift. So we have indeed, under the Black-Scholes model, created a probability distribution on that collection of Brownian motions. We've created a probability distribution that is indeed risk neutral because we had to change the original Brownian motion probabilities in order to absorb the drift term that we embedded in the old Brownian motion in order to make the drift the risk neutral drift. And what Black-Scholes says, another way of saying it, is that the, again, we can write the dt on the right-hand side. It says that under the risk-neutral probabilities, the expected value of dV is equal to RV dt. It says that if you look at any derivative security on the stock, if it satisfies the Black-Scholes differential equation, that's equivalent to saying that the expected value under the risk-neutral probabilities will provide a risk-free return. And that's simply because we have an expression for the risk-neutral dV, and that's the drift coefficient in the process. And the Black-Scholes equation says that that drift is equal to RV.